Again, welcome to a short video on flow control. This is an important topic in any programming language. Normally speaking, flow proceeds from top to bottom with very little break in between. It runs each command one time and it won't do anything else unless you ask it to. And flow control is the process of asking your computer to do something in a different order. Now this is just a short program that I wrote to demonstrate a couple of the concepts of flow control as applied to assembly. It doesn't do very much. It has a short delay loop here, and the part where it loads and stores the letter H into the SCI. So that'll send the letter H over the SCI port. Then it grabs a letter from the SCI, compares it to the letter H. If it gets an H back, it will branch. It will branch specifically just past a command. If it doesn't receive an H, so it didn't branch, then it'll run this subroutine, which I haven't defined, but it's something that would deal with the fact that we didn't get back an H. We evidently expected an H. If we don't get one, we'll have to do something extra. This is pretty simple in sort of C equivalent, and we're going to go through step by step what's going on. Okay, so let's talk about this first loop here, for that's what this is. It may not look like a loop you're familiar with, but that's what it is. First thing I need to do is I need to create another text box. I'm going to try to type some C-style code over here. So first off, what's happening? We're loading the accumulator with an immediate value of 15. And then this is just a label. It says this spot in memory is called loop 1. This command's rather complex long command. It's decrement branch not 0 A, so the accumulator. It decrements the accumulator, and then it branches if it's not 0. So in other words, we enter with 15, it decrements to 14. 14 is not 0, so it's going to branch. Any branch or jump statement has a operand to it. That operand is where you want to go. So in this case, you want to go to loop 1, or you want to go just right back to where you were. Then you'll run decrement branch not 0 A, loop 1 again. If I put more stuff here, if I put something here, blah, 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 I'm typing letters. If I put those letters there, then that would be run. We would decrement branch and loop back, decrement branch and loop back. So this to me starts to look like a for loop, perhaps a while loop, depending on how you want to think about it. In this case, the for loop's pretty empty. This is a delay loop. If we wanted to say I is equal to 15, wanted to spread this out a little bit so you can actually see it. We'll start with I is equal to 15, test if I not equal to 0, and then we'll say I minus minus. And this is pretty much the same for loop. So it starts with 15, it checks to see if that's 0, it decrements down. Technically speaking, this never checks to see if it's 0, but we made it 15. We don't need to check that very first time. And then the very last time, I will be 1, it'll check to see if it's 0, it'll run, it'll decrement, and then it'll check again. It is currently 0, so it'll jump down or move on. It won't execute. And by the way, there's a little semicolon here because we're not doing anything inside of the loop. Similarly here, it'll run 14, 13, 13, all the way down to 1. It'll decrement down to 0 and then not branch. So if we had code here, if we had those random letters here, it wouldn't execute that last time. Okay, this next one's not too complicated. This next one is just basically setting the SCID equal to H. Right, this is something you'd be familiar with in C. Now, technically, you could also use an MOV command that wouldn't load into the accumulator and therefore wouldn't overwrite the accumulator. Not a bad plan if you're doing something as simple as this, but so far we haven't talked about that command. Probably won't have time. And then this next one, we are reading out the SCID, so we're saying maybe X is equal to the SCID, for example. Keeping in mind that that sets this variable equal to that. That's very different. In fact, these are two different pieces of silicon, two different registers that are being read from, even though they have the same name. This is input, this is output. This is where things get a little interesting. So we're comparing with H. What that is doing is that is subtracting the value of this from the accumulator without actually storing the result back in the accumulator. So it simply does the subtraction and then sets the CCR, the condition code register, as if it had done and completed the subtraction. What that means is that you can use some branch statements that depend on the CCR and then another comparison to a different letter if you want to do like a switch case statement, for example. If you had to do a real subtraction, you would have to keep loading back in that same thing. So we'd have to store this value to a spot and then keep coming back to that spot. In this case, though, we can do a comparison and branch if equal. So hopefully you'd recognize that if two values are equal, that subtracting them should then result in 0. Most of the branch statements are written as if they followed up a subtraction operator or a comparison operator. So branch if equal means that the subtraction produces 0 result. Branch if equal, by the way, just checks the 0 bit in the condition code register. And then it branches if that bit is set, if those two values were equal. It goes to received H. That's just down here. Now, what that does then is it skips over this statement. This statement is an interesting statement because it says JSR. That's jump to subroutine, and that's the way that we write functions in assembly. And there's also a branch subroutine command, and we won't have time to get into the details of branch versus jump, but that's the same principle. What it does is it sets the program counter to this new thing, and the difference between a jump subroutine and a conditional branch statement like this is that for the subroutine, it stacks the program counter after the computer has read through this command. What that means is that after it's read through this full command, the program counter is going to point down here at the next line. So it stacks that value. And then when you return from the subroutine, you simply pull that program counter value off of the stack, and then you'll continue execution from here. So unlike a branch, which has no way to get back, there's no way to go back up here. Once you branch down here, you're done. Program counter's been changed, you move on. For a subroutine, you push that value to the stack so that you can come back. In other words, it's more or less exactly like a C-style function, with the exception that subroutines don't have a defined way to return a value. That said, if we want to do this as a C equivalent, I think it's best to think about, okay, if it's equal, skip past, otherwise run this. We don't use goto statements in C. The best equivalent to this, I think, would be to say, if not equal, if it does not equal H, then handle the fact that it's not H. Perhaps this is a function, so it should go like that. If it's not clear to you, program flow is going to go here, or it's going to stop by the subroutine and then come down to here as well. So because either path leads to this, I think it's best to think about this as being an if statement, a negated if statement, rather, even though this says branch if equals, because it skips some code if it's equal. So therefore it runs the code when it's not equal.